continue on, well, I'm seeing this is a square, so I'm aiming for this formula if I can. Oh yeah, I see what's wrong. Now they match. There we go. So can I write this as two squares? That's always the question. If I can, what do you square to get z squared as z? What do you square to get 121/11? So what do? You write them without the squares twice. So you write the z and the 11, the z and the 11 twice. One time minus, one time plus. And there it is. So squares are straightforward. Cubes are straightforward, just the formula is a bit messier to remember or memorize. So if I look at P, first step, greatest common factor, I don't see any, so I would go for, can I make this a square and this a square? What is squared to get 9x squared, 3x? What is squared to get 16y squared? So again, you write it without the squares, 3x and a 4y, 3x and a 4y, one time minus, one time plus. It doesn't matter which one you write first. I like minus first, but that's only me. Personal preference have no significant values. Okay, and here, well, I notice this is not a square, so I'm aiming for a cube because I have two formulas for cubes. What do you raise to the third power to get 8x cubed? That's 2x. What do you raise to the third power to get a cube? A 1. So there, it's a bit different. It's matching this formula. If you write it without the cubes, it seems you square the first. So square the first. You multiply the first and the last. And you square the last piece. The last is always a positive, and the way I memorized it from back in the days, this sign is always the opposite of that. This sign is always the opposite of that. And these three terms are always prime. They never factor. Pretty much you're done right there. They have no solution in R. When we get to complex, we'll talk more about this. Okay, now I look at R. At first glance, nothing I could do, but we skip the first step. Greatest common factor, I don't see any. So I'm thinking squares and cubes, but those tell you that we could write this as a cube, if we could. That would be, what do you raise to the third power to get x to the 6th, x squared y cubed, and a 4z to the 5th. So it matches this formula. The same deal, you write them without the cubes. Times, square the first, multiply those, that's a z, and square the last. The last is always positive. This sign is always the opposite of that, so that's something you need to memorize, and you're done. Now I'm gonna move S. I know it's gonna look odd. I'm gonna move S right there since I have room. I look at this, say, okay, well, obvious squares. So what do you square to get x to the 4th? That is x squared and a 1. So you write them without the squares. X squared and 1, x squared and 1, 1 time minus 1 time plus, and then you say, wait a minute, but that's a perfect square as well. That is x squared, and 1 raised to any power is 1. So what do you square to get x squared x? What do you square to get 1, 1? So you write them twice again. 1 time minus 1 time plus. Don't forget to copy this down. and that's now factored completely. Next problems up, those are what comes up in calculus. See, the following type problems come up in calculus. So we get problems like this and we want to factor those. We notice there are two terms, so I glance at those. I notice there's a 3 there. A 6 is 3 times 2. There's x squared and x cubed. I could factor an x squared out. And there is a 2x plus 1 to the 6, 2x plus 1 to the 5th. Again, we factor with the lowest power. Now if I take this divided by this, 3's cancel out, x squares cancel out, I'm left with 2x plus 1 to the 1. You could put it to the 1 if you want, or you could just write it plus. If I take this term divided by this term, 6 divided by 3 is 2 times 2, that's a 4. The 2x plus 1 to the 5th cancel out, and x cubed divided by x squared is x. So I'm looking at 3x squared into 2x plus 1 to the 5th. 2x plus x, 4x is 6x plus 1. The goal in calculus is to figure out where this equals 0. And to do that, you need to factor it. You could tell at 0, negative 1/2, and negative 1/6. And if you can't factor, you can do the calculus, which causes a big problem. But that's how it is. So it took a lot less than I anticipated. Second problem. Next problem up is a bit tricky. You see fractions and it's kind of challenging. I'll give you a good hint. Ignore the denominators. If I had a to the negative 1 and a to the 2, remember when we factor out the factor with the smallest power. Negative 1 is smaller than 2, so we factor that out. Now, if I take, and now you could put the 3 if you want. So the 3 you could ignore altogether. If I take a to the negative 1/3 divided by a to the negative 1/3, that's a 1. Plus, if I take a to the 2/3 divided by a to the negative 1/3, a to the 2/3 divided by a to the negative 1/3. Don't you take this top power minus that bottom power? 2/3 minus a negative 1/3 is 3/3, which is a 1. Another way of looking at this, you could write it as a to the 2/3, move this up, and when you multiply those, you add powers. So the first time you see this, it's a bit different than what you expect, but that's really what this factors into. Remember, factoring is changing addition and subtraction into multiplication. Next problem up is C, the same idea. All of these are problems that arise in calculus. I notice this is the same. I have a 1/4 and a negative 3/4. So I factor out x plus 2 to the negative 3. Again, if you want to ignore the fourth for now, I'll show you how to do that. Times. If I divide those, if I take x plus 1, x plus 2 to the 1 divided by x plus 2 to the negative 3, isn't that x plus 2 to the 1 plus 3, which is a 4, plus, if I take this divided by x to the negative 3, again, I'm ignoring the 4, that would be x times 1/4 into x into 1. That's it. All what you have to do right now is come back and put in the beginning. That's a good idea if you're really having a hard time with this, until you get the hang of this. X plus 2 to the negative 3/4 times, this will be to the power of 1, so that's going to be x plus 2 plus x over 4. You could take it a step further and say that is x plus 2 to the negative 3/4 times all over 4. 4x plus x is 5x. 4 times 2 is 8. And that would be your final answer. Last problem I have is they both have a 6. I'll take a 6 out. They both have a 3x plus minus 1. I'll take that out. I have a power of 1 and a power of 4. I'll take the least power. And they both have a 2x minus 3. I have a 3 and a 1. I take a 1. Now, if I take this first term divided by this first term, the 6's cancel out. The 3x minus 1 cancel out. If I take 3 over 2 minus, I forgot to put the over 2 and I forgot to put the over 3. 3 over 2 minus 1 over 2 is 2 over 2. And 2 over 2 is 1. Plus, if I take now this term divided by this term, the 6's cancel out, the 2x minus 3 to the 1/2 cancel out. If I take 3x minus 1 to the 4/3 divided by 1/3, 4/3 minus 1/3 is 3/3, which is 1. So this always turns out to be a bit nicer than you like. And now if I was to say, hey, where does this equal 0? You could tell just by glancing at it. And that would be the final answer, and that would conclude